Hey, welcome back everybody. This is part 2 of the Mooer Preamp live repair video. If you didn't watch part 1, make sure you watch part 1 because we made some repairs in part 1 already. Uh, we ended part 1 by removing the codec chip and the DAC chip right here because this 5-volt rail that goes to these chips was not there. So I thought maybe the chips were pulling the rail down, so I removed them, and we still have 0 volts here. So we have to trace this back, figure out what it's connected to, and see if we have any open or shorted components. All right, so this test point here is the 5-volt rail. Okay, and it goes to this chip right here. Let's see. Yeah, right here. Okay, this is the codec chip, and then it goes through this capacitor. Okay, now I have already tested this capacitor, and it's 10 microfarads, and it's perfectly fine. So it also goes to this chip right here, okay, the 5-volt rail, and it goes through this capacitor, okay, to there. So from here to there to there, and I tested this capacitor too, and it's also a 10 microfarad 10 ohm capacitor. It's fine. All right, so let's see if we can figure out where else it goes. Let's see if it goes here. Yeah, it goes to this capacitor. Okay, it goes here. This looks like an inductor, FB3, ferrite bead 3. So this is supposed to be shorted. So that's fine. Okay, so it goes to this capacitor. And this is not shorted. Okay. And the other side of this capacitor goes, let's see where this goes. If we could goes to this capacitor. Okay. And then this side goes to probably ground. Let's see. No, it doesn't go to ground. Okay. Let's see. This, and then this side goes here. And let's see if it goes here. Yeah, it goes to this capacitor. Oh, hold on a second. This capacitor, oh, this looks like it's shorted. Let's see. No, maybe not. Oh yeah, it's shorted. Yep. This capacitor is shorted. And this resistor here, let's see. Yep, that's shorted too. Okay, let's see. This is 0. Well, it could be a low ohm resistor. It's 0, 1, 0, 0, 0, 1D. Okay. Give me 1 second. Let me see what a 0, 1D resistor is. All right. So here are the EIA 96 resistor codes. Okay. And let's look for 0, 1D. 0, 1D, 100K. This resistor should be 100K. But according to my multimeter, it's shorted. Let's check that again. Where'd it go? Right here. Yep. That resistor shorted. And the voltage rail that we're concerned about goes into this capacitor. Out of this capacitor, it goes to that resistor. So this could be our problem. One of these two components is shorted, this resistor or this capacitor or both. So I'm going to take these out of the circuit and let's see what happens. All right, the capacitor is out. Let's see if the short circuit went away. Nope, still shorted. So it must be that resistor. Let's take that out. All right, the resistor's out. Let's see if it's still shorted. And it is. So we got bigger problems here. Something else is causing a short circuit. And we need to trace it back to figure out what it is. All right, so I tested the resistor and capacitor that we just took out, and the resistor does measure 100K, and the capacitor is 100 picofarads. So those were good. So the question is, why do we have a short still? We need to look further, see if we could find it. Let's go away from that for a minute because I just discovered something else. Okay, so we're supposed to have 5 volts here, and we're getting 0. Okay, now if you look where this connects, okay, this goes to this capacitor, and I don't know if you can see, but there's right there, there's a couple of vias. Okay, and let's see, where are they? Right here. Okay, so it goes to this capacitor here, and then that also goes to this capacitor, and there's 2 vias right there. If you go on this side, they're right there, and they go down here and over to here and into this capacitor, which is right here, and goes to the 5-volt regulator. So this rail should be coming from this regulator, but we're getting 0. We're getting 5 volts here, but we're getting 0 here. And let me tell you why that happened. Okay, I fixed it, but here's the problem. Remember in the first video when I said this pad came off? Okay, if you look underneath here, let me see if I can show you. Right in there. Okay, I don't know if you can see that, but I had to go in there and put some solder so that it touches this side of the via, because this pad actually came off, so it's disconnected inside the hole. So now that I did that, okay, let's see if we have continuity. Okay, from this 5 volts, and we do, from the 5-volt regulator to this test point. So now we should have our 5 volts here on V8. Okay, but the question is, why are these two shorted? And I'm beginning to think they're supposed to be that way, because if you look here, if you look, let's see, where was it? Where did I find it? Right here, this capacitor. Okay, it's also shorted. Okay, and it appears to be connecting to ground planes. Okay, but it's shorted. Okay, because it's both sides are ground, and they do the same thing here. I don't know if you can see it right here with this capacitor. Let's see. Yeah, see, it's shorted because it connects this ground to this ground right here. Okay, so maybe these are doing a similar thing here. I don't know. I don't have a schematic, so it's hard to tell. But I think now that we got this 5 volts, I think what I'm going to do is put these back in and put these back in, and let's see if it works. I'm going to put these ICs back in, and now that we have the 5-volt rail, okay, I've already put these two back, even though they're shorted. I think they're supposed to be that way. I don't know. I think they're using capacitors to connect planes. Like right here, they're connecting ground plane with ground plane using a capacitor. So maybe these have something to do with that. I don't know. I don't have a schematic. So we do have the 5-volt rail here now. So I'm going to try to put these chips back in because I think they're still good. And if not, I'll just get new ones. Okay. That looks pretty good right there. So let me tack it down. Okay, that's good just to hold it down for now. All right, I'm gonna use my king bow for this one. Okay, so let me put some in there. That should be good. Should be good. Got to get this perfectly straight. I think that's okay. Let's see. Should be good right there. Put some solder on one side just to hold it down. Okay. And the king bow flux. All right. I think that's good. Yeah, I see some solder bridges over here, so we're not done yet. Okay, that should be good. And right here too. Okay. I think that's good. gonna let that dry, and I'll test for shorts, make sure nothing's bridged, and then we'll turn it on and try it. All right, I'm gonna connect everything here, and we'll give it a spin, see if it works. Hopefully we fixed it, and that's all it was. Okay, that's all right. Now it's in. Okay. All right, everything has been put back together, and before we try it out, I'm gonna make sure we have the 5 volts there. So let me turn it on, and let's see what we have. Okay, do we have 5 volts? Yes, we do. 4.99, 5 volts. So this whole time it was those capacitors preventing the 5 volts from getting there. That this pad was broken. So yeah, let me plug in my guitar and let's try this out. All right, let's turn it on and see what we get. Fingers crossed. Oh. It's working. Boost is working. Post sounds better. Nice. Sounds really, really good. Well, there you have it, folks. It's working, and we fixed it. All right. And it sounds really good, actually. Well, the whole problem was caused by those capacitors. That's the reason we didn't have that 5-volt rail in the first place. So if they would have just spent less than $1 for a P-channel MOSFET, a resistor, and a Zener diode, this could have been prevented. Because that's what it would have cost them. It would have cost them less than $1 to put that reverse polarity protection in there. Oh well. Thanks for watching. See you guys next time.